Alright, so today we will be doing question 2730. Find the longest semi-repetitive substring. So in this question, basically we are given a string. So this is a string or this is a array or whatever. Just so in this string, we say that if two adjacent elements are the same, so we say here, for instance, here, so we see here's a duplication, right? And here it's also duplication or repetition. So a semi-repetitive string is a string that contains at most one repetition, which means at, at most two adjacent elements in this substring are equal. So for instance, if if we look at the blue mark, so here 5 2 is a semi-repetitive string, semi-repetitive substring, and 5 2 2 is also a semi-repetitive substring. However, 5 2 2 3 3 is not a semi-repetitive substring, since there are two duplications, there are two repetitions in this substring. Our goal is to find the length of the longest such substring in the given string. So for instance, in this context, our answer should be our answer should be 5. So the longest semi-repetitive substring is this 2 3 3 4 5. All right. So thinking about this question, since basically the core of this question is to find the substring from a given string from the large string, we want to find a segment of that large string. So I think sliding window may be a good approach to do this problem. So this is how this sliding window works. So basically we need two pointers, the blue pointer and the right pointer. So we put it here. And first, we let the we let the red pointer to go first. Instance is go this way until it reaches a point where the substring is no longer a semi-repetitive substring, right? Then we move the blue string also towards the right, and until at a point we find out that our string is again a valid semi-repetitive parstring. Then we move the right pointer again. Then if we reach a point where our substring is again invalid, then we move the blue string. Then we move the blue pointer. Sorry. Then move the blue pointer again until we reach a point that our string is valid, and so on and so forth. So we repeat this process until the red pointer has passed. Just it has iterated through all the characters in the given string. So it's like actually you can imagine that we have a snake or a turtle here, and it just wiggles and goes back and forth until it reaches the final end. Sorry for my poor drawing skills. Anyway, so this is our basic idea. And how are we going to know whether in a point, let's say our red pointer has reached a point. For instance, our red pointer goes from this 5 all the way to the second 3, and now we see that at this point the substring between the blue pointer and the red pointer inclusively is invalid because we have two 2's and two 3's, and they are just next to each other. So let's think about this case. What actually makes our string invalid? First, we want to know that first, it's the new element, the element we have just included in our string, that may have a possibility to make the whole substring invalid. So it's this 3. So how are we going to know whether this 3 is causing us trouble? We just compare this 3 with the element we have just pointed to, the previous one. So we just compare this 3 with the previous one, which is also 3. So we know here's a repetition, and this 3 may cause us a trouble. And also, we want to know whether the substring has already contained a duplication or repetition. Since if all the elements before these two strings do not contain any repetition, then it's okay for us to have a repetition at this point. However, if there are repetitions, for instance, these two twos before these two threes, then this newly added 3 is truly a problem. So in this point, we need actually another variable to keep a record of the number of duplications we get in our current substring, right? And actually, we do not need an integer variable to actually just contain the number of repetitions, since in this case we only allow the number of repetitions to be 0 or 1. If our number is 1, then any additional repetition, any extra repetition is not allowed. So actually there are just two possible values of replication, 0 and 1. So you can just use a Boolean variable to save us some space, and I think it can make the code, it can make the output and the value of the variable more intuitive and clear, so it's easier for us to debug the code afterwards. And one last question before we go to write the code is that how can we know that at a point if now our substring is invalid, and how can we know just at a point our blue pointer after being moved is just it just makes the substring valid again? How can we know that we have already gotten rid of this problem? Right, so we can just compare. So for instance, at this point, if our blue pointer moves to the second two, we know that we are okay now. And so actually we are just comparing the one pointed by the blue pointer now and the previous one. If they are the same and we have moved to the second one, the second one gets repetition, that means this repetition has been broken, and since this repetition is gone, then the newly added repetition by the red pointer, these two threes, are the only repetitions in our substring, so our substring is safe now. And this approach is and surely this and just and we are actually ensure that this approach, this whole process is going to let us go through all the possible substrings. This way we won't miss the possible longest substring. Why? Since actually we're just moving from the left to the right all the way through, and at each point we just try our best to extend the right pointer to let it move further to the right until it's invalid. Then we adjust the blue pointer to make it valid again. In this process, we have just gone through all the possibilities of valid substrings. So we are we are sure to find the right answer. All right, so let's write the code. So first of all, if our string length is shorter than 3, so which means if there's only like two elements, if there's only just two elements or one element, just two characters or one character in the string, then the whole string the whole string must be valid semi-duplicated string. So the maximum length is just the length of the string. So we can just return as the length, right? However, if in other case we need to do that sliding window, so we initialize the two pointers. So we get the Boolean variable to record if we already have an repetition in our substring, and also we get a max to store the values. So right, all right, so we just make sure that we won't get the index out of boundary problem. and then first we want to just split the cases. So first, if we already have a duplication, then any further duplication is not allowed. So in this case, so oh, wait a minute. I think we should just start the right from the third one. Since when the right pointer is pointing to the first one or the second one, we're ensure that we won't get a invalid substring, right? Since there are only two elements, even if they are the same, it's still a valid substring. However, if the right pointer is pointing to the third one, if all three elements are the same, then we're going to get a problem since there are two repetitions. So we should start with indexed 2, the third one in the array. And then we want to record the duplication. So if s dot char at 0 equals to s dot char at 1, then dupe is true. And if dupe, then we need to make sure that if our write, the newly added one, is causing us one extra duplication. So if char at write is equal to s dot char at write minus 1, then now we know that our string is invalid, and we want to adjust our left pointer. So while we want to first reach a point where we first want to reach the original repetition existing in the array. So for instance, in this point, if we find out that our string is invalid, then we want our blue pointer to find like these two twos, the original repetition. So we need to first reach a point where our we actually want to reach a point where our current left pointer, the element pointed by our current blue pointer, is equal to the previous one. So we want to say that if -1, then we do left plus plus, right, and until we're fine here. So after we go out this while loop, we know that now the string is valid again, and there's no need to change the value of dupe, since even though the previous repetition is cancelled, it's breaks, but we have already introduced another repetition by the right pointer at this step, right? So we're just fine with this case here. And else if there's no duplication, if there's no duplication in the original array, so we want to update the variable dupe if we have just introduced the duplication here. So dupe is equal to true, and since there's no existing repetition in the original subarray, so we do not need to change the left pointer. And at this point we want to first, at this point, now just after this if else logic, we know that our substring now is the valid one, so we want to record its value and possibly update the max. right, and then note that we need to increment the right pointer, right plus plus, and finally we just return max. And let's run the test cases. Alright, I see. Since originally the left pointer is 0, so here's a next out of boundary problem. So we can just change to look at the one on its right hand side. This way, for instance, we're getting a trouble with this newly added 3. So now we just move our left pointer to the first element in the existing repetition. And at this point, we just break the loop. And by doing so, in the while loop, we only compare the blue pointer with the one on its right hand side. So it's always left compared with left plus 1. We won't get in that out of boundary problem. And after stopping here, we do one more left plus plus. Then we just manually move it one step to the right. Then we will be fine. So here, do one further. Right. So let's submit. Alright, so our code is actually quite good. It's in a good shape, and let's do the analysis. So this sliding window, actually our right pointer is moving from the left to the right, just one by one, and our blue pointer is also just following it, moving from the left to the right. So it's just 2n. N for the right pointer and another n for the blue pointer, so it's 2n. And 2n is the same as n, so the time complexity is O(n), and the space complexity is O1, since we only used finite number of additional variables like this dupe and these 2 pointers. No more other additional spaces required. Alright, so here's the problem. See you soon. Bye.